this video, how to prepare PDB files with alternate location records for AutoDock introduces alternate location indicators and explains how to prepare input for AutoDock from files that have them. The molecules in some input crystals for X-ray crystallography may be in slightly different conformations. Consequently, the resulting PDB files have multiple coordinates for a single heavy atom. Here we're looking at one of them. This is file 2wt9.pdb. First we'll find an asparagine residue that has multiple conformations. This column, column 17 in the atom records, records and specifies one of the possible sets of atom coordinates, either A or B for this asparagine. The other thing you should note is over here in columns 55 through 60, the occupancy, the fractional occupancy is written. For this residue, 50% of the atoms were in the A location and 50% were in the B location. Within a single residue, all atoms of a given conformation are assigned the same alternate location indicator. This molecule also has other residues with multiple conformations. For instance, isoleucine in chain A, number 111, has two conformations with 40% of the occupancy in the A conformation and 60% in the B conformation. This molecule even has one residue with three different location codes, A, B, and C. These each contain a third of the density. Here's an example. The residue side chains shown in green in this image are in one conformation, assigned alternate location code A. The atoms in the residue side chains shown in blue are in a different conformation indicated in the PDB file with alternate location B. Protein PDB files can be checked for the presence of these multiple conformations in AutoDock tools. Here's how. First, read in the PDB file you want to check. File, import, fetch from web, and we're going to fetch 2wt9 and then click OK. When a molecule is first read into AutoDock tools, by default, bonded atoms are shown with lines and atoms that don't have any bonds to any other atoms as dots. These red dots you see in the image are waters from the X-ray crystal. So let's just get rid of those. Edit, delete water. Here's how you check for alternate location atoms in AutoDock tools. You use select from string. In the atom window, type in asterisk or star, whichever is easier for you to remember, and then the @ sign, and then another asterisk or star, and click on Add. This will select all of the atoms in this molecule that have an @ sign in their names, which is the PMV convention for these atoms. And you can see that, in fact, now there are 293 atoms in these alternate location, with these alternate location indicators. If you're curious about how many residues these are in, you can change the selection level in AutoDock tools from atoms to residues and see that these 293 atoms belong to 16 different residues. So this file will need some more processing before it can be used with AutoDock. PDB files with multiple conformations can be split into separate files using a script in AutoDock tools called prepare pdb split alt.confs.py. It processes the multi-conformation PDB files creating a new file for each alternate location code. The new files will each contain a single set of coordinates presenting a different conformation of the residue sidechain atoms. Once converted to PDB-QT format, they can be used as input for AutoDock. So here is a live demo. In this directory, I have a symbolic link to the Python script. I also have the PDB file we want to split. If you type the script without its required arguments, it prints a message, a usage message. So let's take a look at that. Here's the usage. You use the name of the script followed by the -r flag and then the file name of the PDB that you want to split. Let's go ahead and do it. You can see that there were 3 different alternate location files in this PDB file, and now if we list what's here, you see there are 3 new files, 2wt9_a_b and _c. Each of these contains a single set of coordinates representing a possible conformation of the molecule in the crystal. Once converted to PDB-QT format, these files can be used as input for AutoDock. Thanks for watching. Please note, if the residues with alternate location indicators are not in the area of the receptor that you're using for your AutoDock binding study, there is another way to prepare the receptor that I'm going to cover now. For example, if you know that the active site is in the area covered by this AutoGrid volume, the AutoGrid box here, we can use a different script in AutoDock Tools Utilities 24 called prepare receptor4.py with the option -u. Let me show you how to do that. Here we are back in the directory we used to demonstrate the prepare PDB split alt-conf.py script. Now we're going to explore the options for prepare receptor by typing it without its required input. As you can see, there are quite a few options, some of which are a bit complicated. I want to bring your attention to the -u option, which specifies what kind of cleanup to do on the input molecule. The default is to merge the charges and remove nonpolar hydrogens and lone pairs, also to remove all the waters and any residues whose type is not in the standard amino acid types. We're going to add the optional option, delete alternate B, delete alt B, which will remove all of the atoms that have an @ sign and then a character other than A, and then it will rename the @A's to just plain whatever the name of the atom is. So let's use this script on our protein. And we'll write it to a new PDB-QT file will be our output. And then for U, we'll specify nonpolar hydrogens, lone pairs, waters, non-standard residues, and delete alt-B. And as you can see, we have created the new file. It has only one set of coordinates for each atoms and can be used in an AutoDock experiment. Thanks for watching.